Now, let's go to an example here using discrete data and finding what's called the expected value, which is the same as finding the mean. We went ahead and looked back at 200 days of how many TVs we sold. We're going back to that story. And we've never sold more than 4 in a day. So we went back 200 days, and out of those 200 days, 80 of them, we didn't sell any TVs at all. 50 of them, we sold 1 TV. 40, we sold 2. 10 of those days, 3. 20 of those days, 4. Now, we need to convert what we just found into weights. What percent of the time, when we went back the last 200 days, did we sell 0 TVs? 80 divided by 200, which is right there, 40% of the data we collected are zeros. 80 of them, 80 of the days out of 200 were zeros. So on average, about 40%, if historical data, the last 200 days, do anything to predict the future, the next 200 days, we should expect about 40% of the time probably selling 0 TVs. 25%, 50 divided by 200, 25% of the time we sold 1 TV. 40 divided by 200, and so on and so on. Notice that when we get done, since these add up to 200, that the probabilities, the weights are going to add up to 100% or 1.0 if you use decimals. So there's where these weights come from. Here are the numbers. Now, define the expected value. All right, you ready? Here are those same weights. Here's the number of TVs. You take each weight and multiply it times the data point and then add the results. Let me say that again. Last week, we didn't have weights. We just had data. We would have added 4 plus 3 plus 2 plus 1 plus 0, then divide by 5. We found the mean. But when there's weights involved like this, we multiply. We don't add these numbers up. We don't divide by anything. We multiply each data point by its weight. 0 times 40%, 0.40, is 0. 1 times 25%, 0.25, is 0.25. 2 times 0.20 is 0.40. 3 times 0.05 is 0.15. And 4 times 0.10 is 0.40. Now you don't divide, you add those results. There's the mean, called the expected value. When you're using weights like this and you're finding the mean, it's called the expected value. 1.2 is our expected value.